we know we've got 25 millimolar, so we've got 25 millimolar NaCl. The same relationship, right? Gram to milligram, right? So in 1 gram, there's 1,000 milligrams. So in 1 molar, there's 1,000 millimolar. So 1,000 millimolar in 1 molar, I've got 0.025 molar solution. I think it's easier though, instead of thinking about it as a molar, it is 0.025 moles per liter. That's molarity, moles per liter. I have a 1 liter solution, so liters cancel out. I need 0.025 moles of NaCl. So 0.025 moles of NaCl, right? I know 1 mole of NaCl. Go to the periodic table, right? Sodium is 23, chlorine is 35.45. So 1 mole of sodium chloride is 58.45 grams. So 0.025. I would go to 2 significant figures, right? So approximately 1.5 grams of sodium chloride need to be added to make that solution. Is question 12 also on the list for tonight? The largest number of nitrate ions in solution. So we want to ionize everything. So that's A, there's B, there's C, there's D. D is 0.1 molar. So when this ionizes, I'm going to get 0.4 molar nitrate because it's 1-to-1. The same thing here. When this ionizes, for every 1 ammonium nitrate, I'm going to get 1 nitrate in solution. So I'd have 0.5 molar nitrate in solution. However, here with calcium nitrate, when calcium nitrate ionizes, I'm going to get 1 calcium, and this 2 comes out in front. I'm going to get 2 separate nitrates. So I'm going to have twice the concentration of nitrate, right? For every 1 mole of calcium nitrate, I'm going to get 1 mole of calcium and twice as much nitrate. So 0.3 molar is going to become 0.6 molar nitrate. This one would be 3 times as much, but that's still going to be less. So I would say choice C, the calcium nitrate is going to give you the highest concentration, the highest concentration of nitrate in solution. All right, what do we need in question 10? We're all set with question 10, Serge? Right, how do we ionize? So aqueous in solution, right? This means it's ions in solution. So I can break this up. I know sodium as an ion is always +1. That makes nitrate, right, -1. So anything that's aqueous, any ionic compound, we can break it up into its respective ions in solution. That's what ionization is. Question 13. Yeah, we may have to cut this a little short. My battery's running out pretty fast, right? Polyatomic ions, they're not solids, they're polyatomic compounds, right? They're not going to ionize because they're nonmetals with nonmetals. So they stay together, right? So in this reaction, to kind of make it a little bit easier, I'm going to keep I'm going to keep everything together, right? Or I'm going to separate things out so it's a little bit easier to see. So iron and iron 3 oxide, right? I've got 2 irons at 3+ each. And that goes to iron 0 because it's an elemental solid. The other one's a little bit harder to see. I've got carbon dioxide, and it goes to carbon monoxide, it goes to carbon dioxide. I can still assign oxidation states by treating it like it's ionic, even though it's not ionic, right? So oxygen is always -2, so that means carbon here and carbon monoxide would be 2+. Over here in carbon dioxide, oxygen is still -2. I've got 2 of them, so I would assign a charge of 4+ to that carbon. So what's oxidized and what's reduced, right? Iron goes from iron 3+, it's going to gain 6 electrons to form iron 0, so that's reduced. So Fe2O3 is reduced. Carbon is actually oxidized. And so we'd say carbon monoxide is actually oxidized. We can treat them like ionic and assign a charge. And so typically the one on the left is the more metallic. So carbon is more metallic than oxygen. And so oxygen as the non-metal, as the most non-metallic, that would be the anion. Carbon would be the cation. Even though it's molecular, we can still kind of apply the rules and treat it like it's ionic, even though it's not. So oxygen as an ion, always 2-. We use that to figure out what carbon is. So yes, even though they're both non-metals, we can treat it like they are ionic compounds. Oxidizing agent gets reduced. So my oxidizing agent, right, Fe2O3, my reducing agent would be that carbon monoxide. All right, I know I got people screaming at me to do question 24 here, but what else was up next? 15. There's a video for 16, so question 15. Oh yeah, this is 2Q equals MC delta T calculations, right? Q of the water equals mass of the water, specific heat, delta T. So for this reaction, right, we know the water, we've got grams of water, we can get the delta T of water, and we know the specific heat of water to find the Q of water. So Q for the water, right, 182.9 grams of water, 4.18 joules, grams, degrees Celsius. My delta T is final minus initials, 28.7. Yeah, I'm gonna have to switch over here.